Good afternoon, everyone. How are you all? So, looks like you're a little bit relaxed, at least after submitting assignment 1. I didn't upload assignment 2 yet. Actually, a couple of students are submitting assignment 1 a little late. So probably they will be submitting at the end of this week, and then I will submit assignment 2 because there are a little bit of clues in assignment 2 in relation to solving assignment 1. That's why just probably I will do it by tomorrow night or at least on Saturday so that you can start working on assignment 2. Yes, I remind you once again that although conceptually assignment 2 will be a continuation of your assignment 1, like in assignment 1 you have prepared a research proposal. So basically you have identified a research issue and you have proposed how to solve it. And assignment 2, you will have data relating to the problem. You will analyze the data and prepare a report. Okay, so conceptually it's continuation. However, practically you will not carry over anything from assignment 1 to assignment 2. Okay, so what I want to say is whatever sampling design, sample size, sampling technique, questionnaire, research approach, whatever you have proposed, that's done for assignment 1. Okay, so assignment 2, you should make a fresh start. Okay, so all the data you will be given, all the relevant information will be given, so you need to make a fresh start. Okay, that's about assignment 2. And also probably I told one of you in the last week that I will be uploading a practice exam. Actually, this is the week we are finalizing our final exam question. Okay, so actually it's not ideal that I upload practice exam question before I finalize the final exam question. So once we submit our final exam question this week, then I will be uploading a practice exam question. once again, probably by tomorrow night or by Saturday. Okay, so you can expect your assignment 2 as well as a practice exam question by the end of this week or by this weekend. Okay, so I will suggest that you start working on assignment 2 and also you practice your exam, and if you have any question related to any of these two, you can contact me, you can send me email, or you can even see me before or after the class. So let's start our today's topic. As I told you in the last class that up to week 6, we basically learned theoretically about the research process, how we do a proposal, what are the different stages in doing a research, how we collect data, how we design a sample. But from today, that means from week 7 onwards, we will actually learn how we can do some statistical analysis. So we will have data and we will be testing some hypotheses using particular statistical technique. So in the lecture session, I will try to theoretically explain the statistical technique, and in the workshop session, I will practically show you how to implement that statistical technique. Okay? I understand that sometimes it's bit difficult or it's bit tricky without practically showing how to do a statistical technique. Just making you understand theoretically, it's sometimes a little bit difficult. Okay, but I will try, and if you feel like that you missed something, don't worry. As we practically do in our workshop session, you will be able to understand, I think, the rest of the concepts. Okay, so our today's topic is Univariate Statistical Analysis. That's chapter 21. So we have 5 learning objectives today. So first of all, we will start discussing with a hypothesis testing procedure. That means if we have a hypothesis, how we actually go for testing this hypothesis. Then we will learn 2 concepts, significance level and p-values. These are 2 very important concepts in hypothesis testing. We will learn the concepts and we will see how we use these significance level and the p-values. We frequently use this significance level, like 5% significance level or 10% significance level. We will theoretically understand what is this, and we will learn how to actually apply this concept in hypothesis testing. Then we will see an example of hypothesis testing procedure. We will be talking about 2 types of error, type 1 and type 2 error, and finally we will learn an univariate chi-square test when it's appropriate and how to do that. So that's actually our learning outcomes today. So first of all, types of statistical analysis. Statistical analysis can be broadly categorized into 3. You can see univariate analysis, bivariate analysis, and multivariate analysis. Okay, that means univariate statistical analysis, bivariate statistical analysis, and multivariate statistical analysis. So from the term, I think you understand the main idea about this. Univariate, bivariate, multivariate. So univariate analysis or univariate statistical analysis involves only one variable. Okay, that means if you have only one variable, if your research hypothesis involves only one variable, then you should go for univariate analysis. Bivariate involves 2 variables. That means if your hypothesis involves 2 variables, your research objective involves 2 variables, then you should go for bivariate analysis. And if your hypothesis involves multiple variables, then you should go for multivariate analysis. Okay. So let's discuss some examples. First of all, univariate analysis. Just before that, we will discuss univariate analysis in this lecture. Next 2 lectures will be based on bivariate analysis, and the lecture after will be multivariate analysis. So today we will be concentrating on univariate analysis. Okay, so let's discuss some examples about all of the three different types of statistical analysis. First of all is univariate analysis. I already have said univariate analysis involves one variable. So can anyone give me an example that you have a hypothesis that involves only one variable and you are testing that hypothesis? A hypothesis that involves only one variable and you are just testing that hypothesis. Any example?
The age of someone, the age of a credit card user influences their usage, or is.
So there are two variables, aren't there?
That's why I slowed down.
Age, age, and usage. So two variables. Then you should go for bivariate analysis. Univariate involves one variable.
Can you give us an example?
I will. I'm just giving you some time to think about.
Women are better drivers than men? No?
Women are better drivers than men. So once again, two.
Two.
Like you should have a sample of men and sample of women, and then you are comparing. Anyone from this side? Yes?
The department is an organization, a unit.
Department, organization, and a unit.
In the organization, a particular unit, like let's say in a sales unit.
Okay, I understand, like sales unit or a particular department. So what's the variable and what you are testing? For example, like he said that credit card users' age and usage, is there any relation? Or like she said that men are better driver than women. So example that I am asking for is you have only one variable and you are testing a hypothesis like this. You want to say anything? Attitude of women?
The attitude of women in different age groups online shopping.
Attitude of women to different age group. So if you measure attitude in different age group, then once again they are no more one. They are different groups.
Area of the square is going to depend on the length of the side.
Area?
Yeah, the area of the square is going to depend on the length of the side.
Okay, so what hypothesis you are testing? Like, you know, the hypothesis means like a statement that you will be testing.
The length side is bigger and the square is bigger.
Length size is bigger, then what?
The area of the square is also bigger.
Area of the square bigger. Okay. Okay. Like you are very close. For example, you are saying that women attitude, or you are saying like age or something. Actually, typically univariate analysis involves one variable when we compare one variable with a particular benchmark or one variable with a particular standard. Okay, because you understand that when you have hypothesis and you are testing, there should be like two sides of the coin, isn't it? Now you might think, okay, if I have only one variable, then how do I test? Actually, you can test if you have one variable in one side and in other variable you have a particular standard. Not a variable, but a standard. For example, like you can say that, okay, the average income level of the people in this city is, average income level is 300,000. Okay? Now, average income level 300,000 that you actually calculate. Now, before calculating, if you are just trying to compare that whether average income level of the people in the city is lower or higher than a particular standard. Let's say 500,000 or 100,000 or whatever. Let's say you are testing customer satisfaction. and you are measuring customer satisfaction in a 10-point Likert scale. And you are expecting that if average customer satisfaction is, let's say, 6, then in general customers are satisfied. Okay? So now if you are testing that if average customer satisfaction is different from your expected level, that is 6, then it will be an univariate analysis. Are you understanding my point? Or let's say you are comparing that average student's score or average student performance if it is same or different compared to the last year performance. So what you are having here is now you have one variable, student performance, but you are comparing with a standard last year average. So that's univariate analysis. Bivariate, yes.
If the every planet revolves around the sun, it's valuable. The univariate planet.
What moves around the sun?
Every planet, just like the Earth.
Every planet moves around the sun, okay? So what's your question?
Yeah, it is the univariate planet.
Univariate variable.
Yeah.
Okay. Now, what's a variable? What's a variable? I understand your statement. All the planets move around the sun.
Yeah.
So what is your variable? Like when we are saying variable, we are saying age, income level, distance.
Planet. Different planet.
Different planet.
Yeah.
Maybe hours or
Like if you say the distance of every planet from the sun, that could be a variable. Like when every planet is moving around the sun, now what's a distance? I know that this distance is not same, you know. When Earth is moving around the sun, this distance changes. That's why sometimes we have summer and sometimes we have winter. Now, if you talk about this distance, then that's a variable.
and time.
Oh,
Time, yes, time will be a variable. But the bottom line I want to say is, if you are focusing on one variable, then you will be using univariate analysis. Okay. The bivariate analysis, it's simple. Bivariate analysis, I think you understand it better. Two variables. Bivariate analysis involves two variables. Okay. Now, two variables. Can you give me some examples? I think now it will be easier to get examples that your research hypothesis involves two variables.
Age of credit card users is a factor in their spending pattern.
Okay. Age is like related to their spending pattern. Okay. So spending is one variable, age is another variable. It's a good example. Anybody else from this side? Bivariate analysis involves two variables. Can you give me an example that involves two variables? Anyone? If you like, that's fine. Okay, you don't have to repeat it. Why don't you say a new one? Okay, let's say you are comparing or you are finding out if there is any relationship between level of development of a country and literacy rate. Okay, so you find out data on level of development, economic development, and literacy rate. You are finding out if there is any relationship. So that will be a bivariate case. You are comparing whether mean income level of men and women are same or different. Then it will be a bivariate case. You are comparing if the income level and the level of expenditure are same or different. Then it will be a bivariate case. Okay. Then the third one is multivariate statistical analysis. As I already have said, that multivariate analysis involves multiple variable. That means you have a hypothesis that involves multiple variable. Any example? You should have more than two variables.
Male, female, age, and spending habits.
Male, female, age, and spending habits. So, like your hypothesis could be if like spending habits is influenced by gender and age. Okay, good example. So here spending habit is one variable, age and gender two more variables. So we actually have three variables. Very good example. Anybody else? Multiple variables?
Lakefront homes that are one story high tend to not have gas connected. Tend to not have gas connected.
Okay, can you repeat again? I forgot what you first said.
So, lakefront homes
Mm-hmm.
that are only one story high
Mm-hmm.
tend to not have gas connected.
So what are the variables?
Lakefront or not.
Okay. Lakefront or not, this is one.
Whether it's one.
The story, yeah, number of a story, that's another, and third one.
Utility connection.
Utility connection. Okay, good example. Okay, so let me give you some examples. For example, if you are doing a research on what are the factors that affect customer satisfaction. Okay, so level of customer satisfaction is one variable. Now, what are the variables you think should affect customer satisfaction? Quality, price. Okay, that's enough for being multivariate because we already have three. So customer satisfaction is influenced by price. What's the other? Quality, price, quality. Okay. Let's say that you are researching on what motivates managers. Like you are working as a manager, what motivates you? What do you think? What motivates manager? Like managers' motivation or employee motivation, if you're variable, then what?
Salary.
Salary, good.
Work-life balance.
Work-life balance, okay. Anything else? Recognition, okay. So these are examples of multivariate analysis. No, sorry, multivariate cases, okay. So the examples that we actually drawn are the cases of univariate, bivariate, and multivariate statistical analysis. I yet didn't say that what statistical test we go for univariate, bivariate, and multivariate analysis, because I think that might be a little bit overwhelming to discuss all these statistical analysis at this moment. Just I tried to give you some idea what are the different cases where we have different statistical analysis. Okay. Now, when we have hypothesis testing, we already discussed some of those points. So when we have hypothesis testing, what are the different hypotheses we test? The first and the most typical hypothesis that we test is relational hypothesis. Okay, relational hypothesis. Relational hypothesis means we attempt to find out if there is any relation between two variables for the simplicity. Okay, that's a relational hypothesis. I already gave you some examples. Like, is there any relation between economic development and literacy rate? Okay, if there is any relationship between poverty rate and child mortality. Okay, so if there is any relationship between economic development and unemployment rate. So these are relational hypotheses. Also, the one as I was discussing, like employee satisfaction is related to salary level, or customer satisfaction is related to product quality. Okay, so all these are examples of relational hypothesis. We check if there is any relation. Do you have any idea what statistical test we use to check if there is any relation between two variables? Any idea?
Univariate.
Univariate. If you go for relational hypothesis, there are two variables. Okay, so you should go for bivariate techniques. Any example? Bivariate techniques. What techniques we actually use? Anyway, no problem. We will be discussing those in the next class. So the first one is relational hypothesis. The second one is hypothesis about differences between groups. That means in this case, we test whether a particular variable is different among the groups. Okay, so try to understand what we test here. We have one particular variable one particular variable, we test that if that variable varies among different groups. Okay? An example? Okay. As I said that, like income level, if income level between men and women are different. So here you basically have one main variable. What's that? Income level. And you're testing that if that's different between male and female. Okay? So if you are testing that if customer satisfaction varies based on different age group, so that will be hypothesis you are testing that whether a variable different from in different groups. The third one, that actually relates to univariate analysis that we will be discussing today. That's a hypothesis about difference from some standard. As I said, univariate analysis, that means whether one variable is different from a certain standard, different from a certain benchmark. So these are the three different types of hypotheses we will be testing. The bottom one, as I said, relates to univariate that we will be discussing today. The middle one is related to bivariate that we will be discussing in the next two lectures. And the first one that might be related to bivariate as well as multivariate. That means that can be a bivariate case or multivariate case. That's the top one that we'll be discussing in the next two and also the week after. So what's the hypothesis testing procedure actually? As I already told you that I will theoretically discuss the procedure here, and in the workshop session we will actually see the practical procedure to test a hypothesis. So when we have a hypothesis, we need to understand that hypothesis actually should be derived from your research objective. You can remember we learned about research process, the stages of research. So first of all, you need to write down a research objective, and research objective should be translated into research hypothesis. Okay? And once you have your research hypothesis written, then you should collect data, you should construct or measure your variable. Okay? Then what you need to do, like if you have a variable, then try to find out the sample value of or sample parameters of the variable and compare the sample parameters or sample values with a value that is explicitly or implicitly implied in your hypothesis. That means this is your sample value, compare it with something that you have explicitly or implicitly implied in your hypothesis. If that sample value is consistent with a value that you imply in your hypothesis, then the hypothesis is supported. If not consistent, then hypothesis is rejected. Okay? Let's take some examples. What I have said, the last one, this is important, the last step, that means step number 3. So once you have your hypothesis done, you collect your data and construct your variable. Now what you do, you get some sample values. As I'm saying, sample values. So what is the meaning of sample values? For example, as I said, that like you are measuring if customer satisfaction is same or similar to management expectation. So customer satisfaction was measured in 1 to 10 Likert scale, and you are expecting that customer satisfaction should be equal to a management expectation that is 6. That's the average customer satisfaction you are expecting. Okay? So customer satisfaction equals to management expectation 6. So this is, customer satisfaction 6. That is 6. That is what you have stated in your hypothesis. Now you have your actual customer satisfaction data. Calculate the average and compare your actual average with what you are explicitly stating in your hypothesis. If your actual sample value is consistent with what you are stating in the hypothesis, then your hypothesis is supported. If not, then hypothesis is rejected. Now be mindful, as I said, that we will get the sample value and we will compare it with a value that is explicitly or implicitly implied in the hypothesis. What is the meaning of this statement? Explicitly or implicitly implied in the hypothesis. Explicitly implied means you categorically write down what should be the value of your variable. Okay. For example, as I said, that customer satisfaction is equal to 6. Okay. So that is explicitly implied. Now, it does not necessarily mean that you will always have an explicit value in your hypothesis. May not. Okay. It may be implicitly, not explicitly, but it may be implicitly stated. What's the meaning of implicitly stated? For example, as I said that, let's say that income level of male and female are same. That's your hypothesis, that income level of male and female are same. Now look, you have a value in your hypothesis, but that is not explicit. Are you explicitly writing that men's income level is this and female's income level is this? No, you are not. You are just implying that they are same. Now, what you do is you actually calculate what is the average income level of men and what's the average income level of female. Compare them and find out if that is consistent with what you are implying in the hypothesis. What you are implying that they are same. Actually calculate them and test them. If they are consistent with what you implicitly have specified in your hypothesis, if that is the case, then you accept your hypothesis. If not, then you reject the hypothesis. That means if you find that the men and women's income level are not same from your actual data, that means it's not consistent with what you implied in your hypothesis, so you reject the hypothesis. So theoretically that's the process we go for hypothesis testing. Okay, now we are talking a lot about hypothesis. I previously, in some occasions, have tried to define what hypothesis is. Just once again, when we say we write down a hypothesis, what do we actually mean? As I said that, to be simple, hypothesis is a statement. Hypothesis is a statement that can be empirically tested. This is very important point. Hypothesis is a statement that can be empirically tested. You understand the meaning? Empirically tested? What does it mean? A statement that can be empirically tested. With facts, okay. Empirically tested means we can collect data, and using this actual data, we can test this. Okay. So, for example, when we say that customer satisfaction is influenced by product price. So, can this be empirically tested? Can we collect customer satisfaction data and product price data, and can we actually test? If so, then that meets the condition of a hypothesis. Okay, we write down a statement that can be empirically tested. Or in other words, we can say that hypothesis is a statement that is unproven or that is actually explaining a certain phenomena that we will prove. Okay, so when we are writing a hypothesis, we are writing or we are trying to explain something that yet not proven, that we will actually prove. Okay, that we will actually prove. Or you can other way you can say you are just making an assumption. You are making an assumption, but you will collect data and you will test that whether your assumption holds or not. Like income level of male and female are same. So this is an assumption you make. What you will do is you will collect data and you will actually test whether this hypothesis holds or not. Now, when we write down our hypothesis, it's a statistical convention that we write down two hypotheses. For each of the objective or each of the assumption, we write down two hypotheses. We call it null hypothesis and alternate hypothesis. Okay? We actually write down two, a pair of hypotheses for each cases. Null hypothesis and alternate hypothesis. So when we write down null hypothesis, this is important, carefully try to understand. When we write down null hypothesis, we write down in a way that it represents a status quo, okay? Or it represents that the sample and population values are same, or the two sample values are same. We write down the null hypothesis in this way, okay? I repeat, when we write down null hypothesis, we write down it as a statement of a status quo, okay? We write down it as a way that there is no difference between sample and population values, or there is no difference between two sample values, okay? So if we are testing that customer satisfaction is same across genders, then null hypothesis will be customer satisfaction male equals to customer satisfaction female. Is it all right? If we say that if we are testing that if customer satisfaction varies on the age group, then the null hypothesis will be customer satisfaction of age group 1 equals to customer satisfaction of age group 2 equals to customer satisfaction of age group 3. Okay? If we are testing that if there is a relationship between economic development and literacy rate, then our null hypothesis will be there is no relationship between economic development and literacy rate. Okay? If we are testing that employee satisfaction is influenced by salary level, our null hypothesis will be there is no relationship between employee satisfaction and level of salary. This is the conventional way we write down our null hypothesis. Okay? Now, what is alternate hypothesis? Actually, alternate hypothesis will be just opposite of null hypothesis. Okay? So, when we write down our alternate hypothesis, we actually specify that if our null hypothesis doesn't hold, what actually holds? Okay? You get my point? If null hypothesis doesn't hold, then what actually holds or what actually true? For example, if we say that there is no relationship between economic development and literacy rate, then alternate hypothesis will be what? Anyone? What will be alternate hypothesis? Null hypothesis is there is no relation between economic development and literacy rate. What will be alternate hypothesis? There is a relationship. There is a relationship between economic development and literacy rate. Okay. Anyone else? Any other alternate hypothesis? There is a relationship between economic development and literacy rate. Any other alternate hypothesis possible? Good. Alternate hypothesis can be that there is a positive relationship between economic development and literacy rate, or there is a negative relationship between economic development and literacy rate. So, the reason I am asking that what alternative hypothesis can be written in this case is when you write down your alternate hypothesis, as I said, that you specify that if null hypothesis is not true, then what is true? What you are testing as an alternate. So there is a relationship, or there is a positive relationship, or there is a negative relationship, what you are testing. So that's the alternate hypothesis. Okay? So this is the way we write down our null and alternate hypothesis. So as I was mentioning that hypothesis should be derived from research objective. So is there anyone who would like to share like what research objectives you mentioned in your assignment 1 and what hypothesis you can derive from these research objectives. Anyone wants to share?
Tristan will.
Like what objectives you mentioned? That this is the research objective I mentioned, so I can derive this hypothesis. Anyone? Yes.
Use of internet. Frequency of use of internet banking decreases with age.
Frequency of internet banking, frequency of using internet banking reduces with age. Okay, so that's your hypothesis. So what was your research objective?
Whether there is a change in age.
Okay, so if there is any relationship between age and frequency of using internet banking. Okay, good. Anybody else like research objective that you actually written and hypothesis you can derive? No one?
I'll read you mine from my son.
Yeah.
After consultation with the user, the following research objectives have been identified. 1. To identify consumer awareness of Visa's online security systems. 2. To assess consumer perceptions as to the adequacy of the online security systems. 3. So there are multiple things here.
Okay, so do you want to identify any particular one that you want to derive hypothesis?
The first one.
Okay.
To identify consumer awareness of Visa's online security systems.
Okay, to identify consumer awareness of Visa security system. Okay, so what hypothesis will you derive?
Consumers have an awareness of Visa's online security systems.
Customers say having awareness. That means customers are aware about the Visa's security system. Okay. You wanted to say anything? No? Okay. Okay. So actually why I am asking this question, like keep it in mind that each stages in research are interrelated. Okay, and this is very important that when you write down your research proposal, it becomes a coherent one. Okay, this is very important, and this is also like the major weakness when we prepare a research proposal, because when we write down the research objective, we do not think what hypothesis we will be testing. Okay, or when we write down hypothesis, we do not think what variable or what data we will need and how we will measure that data. Okay, so that's the problem, that we fail to relate or we fail to integrate each stages. Okay, so when we write down our research objective, at the same time we need to keep it in mind that whether we can write down a good hypothesis or not. And if we write down a hypothesis, to test the hypothesis we need data, whether we will be able to collect this data or not, and whether we will be able to test that or not. So you need to think this entire process at a glance. Is it okay? Because sometimes I have seen that you write down your research objective, then you develop your questionnaire in a way that I find that there are a lot of questions that do not have any relation with any of your research objective. Okay. And also I find that there is no question that contribute like achieving some of the objectives. So you write down some objectives, but it's not sure how these objectives will be achieved. Okay. Or you include some questions that I do not find that how that will be helpful in achieving your objectives. That's why we need to integrate, or we need to think this entire process at a glance. Okay. Now, statistical significance and p-values. These are two technical terms we use when we go for hypothesis testing. So, first of all is significance level. Okay. I know that the definition that is given here is very much like a very mechanized type of definition. So let me try to make it a little bit simple or understandable. When we talk about significance level, okay, so when we test our hypothesis, we first of all have a preset significance level, okay? Preset significance level. What is this preset significance level? This preset significance level is generally from 1% to 10%. Okay, that means when we test our hypothesis, we test it at a significance level of, let's say, 10%, 5%, or 1%. These are the most commonly used three preset significance level. Again, I said, what are these? 1%, 5%, and 10%. Preset or predetermined significance level. So what this preset significance level is? Conceptually, this significance level is basically a critical probability. Try to understand the word critical. It has a different meaning in statistics than we generally know. Okay? So when we say a critical value, it's actually a it's actually a benchmark value. Okay? It's a benchmark value, or it's a predetermined value, or it's a preset value. Okay? When we say critical value. So the significance level is a critical probability that how likely that a statistical inference we draw about a difference between two variables or difference between one variable with a standard, how likely that inference or this expectation is true. Okay, let me make it simple. You know, when we write down a null hypothesis, we have an expectation about the difference between two variables. Yes or no? For example, if we write down our null hypothesis that there is no relationship between level of income and level of expenditure. So what is this? This is an expectation we have. What's the expectation? No difference. No difference between level of income and level of expenditure. So this statistical expectation, when we say significance level, actually we indicate that what is the likely that this expectation that we are making, what is the likely that this expectation is true? Okay, that's a critical probability. Now, what is p-value? If significance level is a critical probability, then p-value is a computed probability. Okay, that means, as I said, that significance level is a preset one or a predetermined one. P-value, then p-value is a calculated one. That is actually calculated from our data. Okay, calculated from our data. So this is also a probability that, that's how much likely our expectation about the relationship is true. Okay, so both are probability, significance level and p-value, both are probability, but the difference is significance level is a preset or predetermined probability and p-value is a calculated probability. Okay, now how we actually decide that whether we accept or reject a hypothesis? We compare the p-value with our significance level. Okay, and if the p-value is less than the significance level, okay, p-value is less than the significance level, it means that there is a very low chance that the null hypothesis is true. Okay, so look what I am trying to say. I am trying to say that p-value is a calculated probability, calculated from our data. It's a calculated probability that how likely the statistical expectation that we write down in our hypothesis, how likely that is true. Now, as we are comparing this p-value with our significance level, What's the significance level? I already said 1%, 5%, 10%, and so on. So if this p-value is less than the significance level, less than the significance level means there is a very low probability that the null hypothesis will be true. That means the expectation that we make, it will be true. It's a very low probability. So when p-value is less than the significance level, we reject our null hypothesis. Okay? We reject our null hypothesis, and when the p-value is greater than the significance level, we accept our null hypothesis. Do you understand my point? So actually p-value lower than the significance level indicate that the probability that our expectation is true is less than our preset probability. So we reject our null hypothesis. Whereas if p-value is greater than the significance level, that means the likelihood that our expectation is true is higher. So we accept our null hypothesis. Okay? Previously, we used to calculate this p-value from the data, but nowadays, since we have different statistical softwares, the statistical softwares provide us this p-value, and as I said, that we already have some preset significance level. So we compare the p-value derived from the data, we compare it with the significance level, and if we find that our p-value is less than the significance level, we reject, and otherwise we accept. Now, look at this example. This example has been taken from your textbook. Unfortunately, there is a small error in the textbook in this diagram. So if you look at this diagram, look, we have a sample mean. Okay, so if you look at this distribution in the right, this is the distribution of your data. Okay, that means the actual distribution you have, and this is the mean. That means you calculate from your data. Okay, and this is a standard. As I said, that univariate analysis. What is univariate analysis? You will compare one variable with a certain standard. So this is your sample mean that you calculate from your data, and this is your standard. So what you will do is, you will compare your sample mean with your benchmark. Okay? So how do we write down our null hypothesis? As I said, that we write down our null hypothesis that there is no difference, or they are same. So in this case, our null hypothesis will be the sample mean is same as the standard. Yes or no? Sample mean is same as the standard. So if this sample mean is same as the standard, that is our null hypothesis. Now, closer this sample mean with this standard, higher the probability that our expectation about the relationship is true. Yes or no? Try to understand. This is our sample mean. What is our expectation? That means what is our null hypothesis? That the sample mean and this standard are same. That's our expectation. Now when this expectation will be true, that means what's the probability that expectation will be true? As this sample mean gets closer and closer to this standard, there is a higher probability that the expectation that you make that they are same, higher probability that they are true. Yes or no? Okay. On the other hand, if this sample mean goes away from this standard, sample mean goes away from this standard, there is less likely that our expectation is true. Yes or no? Okay. Now look at the p-value below. The p-value basically derived in such a way that, look, when this is your sample mean and this is your standard, as the sample mean gets closer and this is your p-value, look, your p-value gets larger and larger. Okay? P-value, look, this is 0. Actually, that should not be 0. That should be 1. Okay? So as your sample mean goes closer to your standard, your p-value gets larger. As I already have said, larger p-value means there is a higher probability that your expectation is true. On the other hand, as this sample mean go away from your standard, your p-value gets smaller, smaller, and smaller. So as your p-value gets smaller, it means that there is a very low probability that your expectation will be true. So very low probability your expectation will be true means you actually reject your null hypothesis. Okay? Now, if you, for example, if you take this p-value 0.0001, if this is the p-value, should you reject your null hypothesis or you accept your null hypothesis? P-value is 0.0001. Accept or reject your null hypothesis.
Do you want?
Hmm?
Do you have a choice of either?
Choice of either?
Like you choose either or, like it could be null or
Well, first of all, we need to understand how do we choose? How do we decide?
Based on the significance level?
Based on significance level. Good. So first choose a significance level. Let's say 5%. Okay. So these p-value need to be considered with significance level. Let's say 5%. Now, is this p-value is less than 5% or greater than 5%? 0.0001. Is it less than 5% or greater than 5%? It is less than 5%. So I already have said that when your actual p-value or your calculated p-value is less than your preset significance level, it means that there is very low probability that your null hypothesis will be true. So in this case, if your p-value is this, you reject null hypothesis or you accept null hypothesis? You reject your null hypothesis. You reject your null hypothesis. On the other hand, if your p-value is this, 0.5, so is it greater than 5% or less than 5%? 0.5. Is it equal to 5%, less than 5%, greater than 5%? Greater than 5%. It's greater than 5% because 5% actually means 0.05, isn't it? So it's 0.5. It's 0.5 means it's greater than 5%. So it's 50%, you're right. So it's greater than 5%. So it's greater than 5%. So should you accept your null hypothesis or reject your null hypothesis? Accept your null hypothesis. So theoretically try to understand. This is your benchmark and this is your sample mean. So when your p-value is here, that means your sample mean is here. It means that your sample mean and your standard is very close. So you accept your null hypothesis that they are safe. But when your p-value is here, 0.0001, your sample mean is here and your standard is here. It's much away from sample mean. So your null hypothesis that they are same is rejected. You understand my point? Is it clear or not? Okay. I understand that it's like sort of elusive type of concept because like I didn't show you how do we actually calculate p-value and so. That's why sometimes I feel like our time was better because when I was a university student in undergrad level, when we actually had statistical courses, it was in late 1990s. I actually started my university in the year 1995. So I'm actually old. So at that time, we didn't have computer in our classrooms. So all these calculations we need to do manually by using calculator. So actually we got a more first-hand experience that how we actually calculating p-value, we are actually getting this mean value, whether they are same or different. But now you know, this is statistical software, it gives us all results. So since the software gives us all results, I cannot tell you, can you use your calculator and calculate all of this? I cannot tell you. So you don't do your calculation, you get all the results in front of you. So what we need to do, we need to theoretically explain everything. Now you know, that's a statistical technique or a technical issue explaining theoretically is not that easy. Okay, that's why I understand that probably some of you are still thinking, okay, why it's happening, how it's happening. But I tell you that you will have more relatively better idea, clear idea when we test all these in our workshop session. Anyway, so just if I draw a bottom line here, theoretically, we compare our p-value with the significance level. Significance levels are the preset probabilities, whereas p-value is our computed probability. So p-value basically indicates that whether our expectation about the statistical relationship is true or false. And don't forget that our expectation is actually indicated by our null hypothesis, that they are same. So higher p-value means there is a higher probability. Just think in this way, then it will be easier for you to remember. Higher p-value, p is the probability value. Higher p-value means there is a higher probability that your null hypothesis is true. Is it okay? And lower p-value means there is a lower probability that your null hypothesis is true. Now higher, lower, when we say higher, lower, you know, to actually decide whether it's higher or lower, you need a benchmark, or you need a predetermined value that is your significance level. So if your p-value is higher than your significance level, you accept your null hypothesis. That means your null hypothesis is true. Whereas if your p-value is less than your significance level, that means there is a low probability that your null hypothesis is true, so you actually reject. You reject your null hypothesis. But we will practically do these tests in our workshop using our data. Okay, now we will be talking about some errors like type 1 error and type 2 error. Actually, why the discussion of error is relevant? You understand that all of we do is some statistical test, and we actually compare the mean of a variable with that of another variable, and also we try to draw some inference from a sample about a population. Okay. Look, when we say that income level between male and female are same, okay, if we have a null hypothesis that income level of male and female are same, and we accept our null hypothesis, what? That income level of male and female are same. Does it necessarily mean that each man and each woman has the same income? Does it necessarily mean? It does not. It does not. Why? Because when we are drawing an inference, that's actually is comparing the means, or that actually comparing a sample value, and we are deriving a conclusion about our population. Okay, that's why it's very normal that statisticians cannot claim to be 100% true, cannot claim to be 100% correct. Okay, so as we go for hypothesis testing, there are two types of error. Conventionally, we call them type 1 error and type 2 error. So type 1 error is, look, we have a null hypothesis, right? Null hypothesis. Now, ideally, if our null hypothesis is true, we should accept it. Yes or no? That's what we should do. If our null hypothesis is true, we should accept it. If we reject our true null hypothesis, that means a null hypothesis is true, instead of accepting, we reject it. Then we do an error that we call type 1 error. That means, what is type 1 error? Type 1 error is the probability that we reject a true null hypothesis. Okay? So your null hypothesis is true, but you reject it. That's the type 1 error. Now, what about type 2 error? Now, the first one is related to if your null hypothesis is true. Now, the second one is related to if your null hypothesis is false. If your null hypothesis is false, what you should do? Ideally, what you should do if your null hypothesis is false? You should reject it. If your null hypothesis is false, you should reject it. But mistakenly, if you accept a false null hypothesis, then the error that you incur is type 2 error. Okay, so type 2 error is the probability that you accept a false null hypothesis. Is it all right? So, as I already mentioned that when we go for hypothesis testing, we can either incur type 1 error, type 2 error, and type 1 error is the more typical one we do. So, when we reject a true null hypothesis, that's type 1 error, and we calculate the probability of this type 1 error, and we indicate it by alpha. Okay, so alpha, when we have we calculate our alpha, that actually indicates what's the probability or what's the chances of making a type 1 error. And type 2 error, we indicate it by beta. That means when we calculate beta for a hypothesis testing, this beta actually indicates the probability of type 2 error. Type 2 error, as I already said, that if your null hypothesis is false, you should reject it. But if you accept it, if you accept a false null hypothesis, that is type 2 error. Okay. So in hypothesis testing, we conventionally calculate this alpha and beta, and we look at what is the probability of this probability of occurring this type 1 and type 2 error. Now, so once we understand different statistical analysis, we understand different hypothesis testing, now we need to decide what appropriate statistical technique we should use. Okay, so what appropriate statistical technique we use, that depends on these three factors. First of all is type of question to be answered, the number of variables involved, then level of scale measurement. Okay, let's start with point number 3, level of scale measurement. You know that there are 4 measurements level in our data. We learned about 4 measurement level. You can remember this? Different measurement levels. Nominal, ordinal, interval, and ratio. Okay. So, first of all, what statistical technique you will choose, that depends on the level of measurement scale. It means that if your variable is measured in nominal scale or ordinal scale, you will be using a particular statistical technique, whereas if your variable is measured in ratio scale or interval scale, then you will be measuring your variable in a different scale. Okay, you will be measuring your variable in a different scale, and you will be using a different statistical technique. Okay, so that's very important. As I just keep saying that it's very important that you understand the measurement scale of your data, because that dictates what statistical technique you will be using. I will be shortly showing you a diagram that shows what are the different statistical techniques used for different measurement scales. The number of variables involved. I already have said that how many variables you have, that determines what type of analysis you will be going for. For example, if you have only one variable, then you will be using univariate analysis. If you have 2 variables, then you will be doing bivariate analysis, and if you have multiple variables, then you will be doing multivariate analysis. Now actually, this multivariate analysis or bivariate analysis, these are not a statistical technique by name, they are actually a broad category. So under bivariate analysis, there are specific statistical techniques. Under multivariate analysis, there are particular statistical techniques. So if you have different variables, and different variables means different number of variables, then you should decide that what statistical technique you should be using. For example, if you have like a bivariate case, if you have 2 variables and you are looking for a relationship between them, 2 variables, and you are looking for relationship between them, do you have any idea what statistical technique you will be using? You have two variables and you are looking for a relationship between them. Any idea what is statistical technique?
Bivariate. Bivariate.
Quadrant.
Bivariate.
Bivariate. Well, bivariate and multivariate, these are actually broad category. Now, under bivariate, you have specific technique, or under multivariate, you have a specific techniques. Bivariate is all right, but what is specifically under bivariate? Okay, I understand that we didn't discuss them yet. Have you heard about correlation analysis? Correlation? Have you ever heard? No? Okay, if you have two variables and you are looking for the relationship between them, then probably correlation is a suitable technique. If you have multiple variable, and you are looking for a relationship between one variable with all others, for example, customer satisfaction determined by price and quality. So if you want to find out the relationship, if customer satisfaction is influenced by these two variables, any idea what statistical technique you should be going for? Customer satisfaction if influenced by product quality and price. What is statistical technique you can use? Have you heard about regression? Regression? No? Okay. So we will be discussing all of them, correlation and regression. So when we are looking for this relationship between two variables, correlation between multiple variables, regression, probably good. If we are looking for the difference between two variables, like as I said that income level of male and female, or income level of different age group, or customer satisfaction male and female, or customer satisfaction different age group. So if we are comparing mean between two variables, then t-test, we call t-test, that we will be discussing today, we call t-test. T-test can be a good test. And if we have multiple variables comparing the mean, whether they are same or not, then we go for one statistical technique, we call it ANOVA, analysis of variance. Okay, so the point I want to say that first of all, level of scale measurement will tell you what statistical technique you will be using, and second, the second factor that you will decide that what statistical technique you will use is the number of variables. Number of variables is important determinant that what statistical technique you use. And last of all is the type of question to be answered. So this point we already discussed. Type of the question to be answered means what you are actually analyzing. Okay? What you are actually analyzing. That will let you know that what is statistical technique you should go for. For example, let's say you are comparing sales of a salesperson. Now, you may have different question. Let's say you have a question that if the salesperson's sales achievement is different from the average sales of the company. Okay, that means let's say there are 100 salespeople, and you are finding out if one individual's sales performance is different from the overall average of the company. This could be one question. Another question could be you are comparing employee performance of two different divisions. Like, is the employee performance of sales department and employee performance of production department, are they different? Okay? And let's say you are comparing that if the sales performance of different regional sales office are same or not. Let's say you have 10 regional sales office, if the sales performance, these 10 regional sales office are different. So if you carefully follow these questions, the questions are different of nature. In the first one, you are comparing one person's sales performance with the company average. In the second one, you are comparing the employee performance of two different divisions. And in the third one, you are comparing the sales performance of different regional units. So this type of question will determine what statistical technique you will be using. Okay. Another concept you need to know in this stage is parametric statistics and non-parametric statistics. That means all statistical techniques that we use in our statistical analysis can be classified into two broad categories. One is parametric statistic, another is non-parametric statistic. That means sometimes we may wonder that whether we should use a parametric statistical technique or a non-parametric statistical technique. If I be simple, how to differentiate between this parametric statistic and non-parametric statistic, I can say that parametric statistical techniques assumes that the variable or the data is normally distributed. Okay, that means if you have a variable and that variable is assumed to be normally distributed, then you should use parametric statistics. Okay, that's the simplest explanation. On the other hand, if you assume that the variable that you're analyzing, that variable is not normally distributed, that means that's non-normal, then you may use non-parametric statistics. Okay, there are some other characteristics. For example, parametric statistics are used particularly in the case of large sample size, and particularly when our variables are interval or ratio scale variable. However, non-parametric statistics are used in general, as I already have said, when you assume that the data is not normal. Additionally, if your sample size is relatively smaller, and the data is interval or ratio scale, then you should use non-parametric statistics. Okay, so broadly classified statistical techniques are parametric and non-parametric statistics. We need to understand that in general, non-parametric statistics have less statistical power and less statistical accuracy compared to that of parametric statistics. Okay, so if you take a parametric statistical technique and non-parametric statistical technique, in general, non-parametric statistical technique has less degree of accuracy. So given this foundation, now let's see some examples of statistical techniques. So at the top you can see this is univariate statistical choice made easy. Okay, so what do you mean by univariate statistical choice made easy? Actually, if you follow this diagram, you should get important guide that which statistical technique you should use, which statistical technique you should follow. First of all, as I already have said, the first determinant of what statistical technique you should use is you need to know whether your variable is interval or ratio, whether your variable is ordinal, whether your variable is nominal, or if they are nominal proportions. Okay? So this is the first determinant, that what statistical technique you use, that what's the measurement scale of your variable. The second determinant is what is the type of question you are answering. Okay? Type of question you are answering. For example, look, is sample mean different from hypothesized value? Is sample mean different from hypothesized value? Can you remember I said that when I was giving an example of sales performance, I said that let's say you are comparing the sales performance of an individual with that of the company average. Okay, so if that's an interval or ratio scale and this is the type of question you are answering, then you should use Z-test or T-test. then if you have ordinal or nominal, for example, if you have ordinal and your question is are rankings evenly distributed, then the statistical test we should use is chi-square test. Okay, are ranking evenly distributed? What does it mean, are ranking evenly distributed? We will see an example today that, let's say that a restaurant is located in two different locations. There are some branches, they are located in shopping malls and some located in standalone locations. Okay, now you have an expectation that they are equally distributed in standalone location and shopping malls. It's possible that you actually collect data that how many of the restaurants are located in shopping malls and how many are located in a standalone location. That's your actual data. And your expectation is they are equally distributed between a standalone and shopping centers. So what you can do is you can compare these two. That is actually what you are doing here. Are rankings evenly distributed? Okay. So in this case, we are not comparing mean, rather we are comparing the distributions, whether they are equally distributed or whether they are similarly distributed. Then the statistical test we use is chi-square test. Nominal is number in each classification equal? Each number in each classification is equal. We go for Kolmogorov-Smirnov test. Okay. So this Z-test and T-test, if you look, this Z-test and T-test, they are parametric test, and chi-square test and Kolmogorov-Smirnov test are non-parametric tests. We will not discuss these one. So we will be discussing T-test and chi-square test. Okay. I already have said that this parametric test is based on the assumption that the data is normally distributed, or at least we know about the distribution. However, chi-square test, this is called chi-square. Chi-square test is a non-parametric test or non-parametric statistic because that's not normally distributed. At the same time, we do not know what is the distribution, because you know when you have a nominal or ordinal data, you cannot know what is the actual distribution is if you do not have a continuous variable. So if you have a continuous variable, for example here, then continuous variable, you know what's the distribution, so you can go for parametric statistics. But in this case, in case of nominal and ordinal, your data is, for example, yes, no, yes, no, yes, no. So you don't know what's the distribution, because for like 0, 1, 0, 1, 0, 1, you cannot draw a distribution, can you? You cannot draw a distribution. So as you do not know what your distribution is, there is no question of being normal, and you cannot use parametric test. So what you use? Non-parametric test that we call chi-square test. Another choice or another decision that we need to take about our hypothesis testing is whether we should go for a univariate test or a bivariate test. So now, whether a one-tail test or two-tail test, not bivariate test. So here we will be talking about T-test. Okay, that's the univariate test that we will be discussing. So what a T-test is, actually T-test is particularly suitable when we compare a sample mean with an observed mean. Okay, that means you have a sample mean and you compare it with an observed mean. So in that case, we go for a T-test. Now, this T-test, when we do T-test, we can either go for one-tail test or we can go for two-tail test. So that's also a statistical decision we need to take, that whether we should go for one-tail or two-tail test. Actually, we need to understand what we mean by this one-tail and two-tail test. You can remember a probability distribution. We have seen it earlier. For example, a normal distribution. In a normal distribution, the middle of the distribution is the mean value, you can remember, and half of the distribution is in right of the mean and half of the distribution is the left of the mean. Now, when we use one-tail test, if our hypothesis involves only one side of the distribution, then we use one-tail test. And if our hypothesis is related, or if your hypothesis involved both sides of the distribution, then we use two-tailed test. You understand the meaning of this? Hypothesis involves only one side of the distribution. What does it mean? Look, if you have a distribution and mean value is the middle of the distribution, now I am saying that if your hypothesis involves only one side of the distribution, it means that if your mean is compared, that whether it is higher from a certain standard, so that means it's related to only one side of the distribution. Or if you compare that if your mean value is lower than a certain benchmark, it's related to only one side of the distribution. So we go for one-tailed test. Okay. On the other hand, if we check that is the mean value different from a benchmark? Try to understand my point. What I said first, when we use one-tailed test, we are testing if the mean value is greater than the benchmark. Okay? Mean value is greater than the benchmark. That's a one-tailed test. Or mean value is smaller than the benchmark. That's a one-tailed test. If we test if the mean value is not equal or mean value is different from the benchmark, then it's a two-tailed test. You understand why?
You test both sides.
You
have to test both sides.
We test both sides. Like when we are saying that mean value is greater than standard, we are actually testing if that is greater. Okay? That's why it's a one-tailed test. Or if we say that mean value is less than standard, that's a one-tailed test because we are testing if that is smaller. But if we say that if mean value is not equal to the benchmark, so we are testing both. Not equal to means it can be either greater or smaller. So that's a two-tailed test. Okay. So when we are having a particular hypothesis and we are testing it, we may need to decide that whether we should go for a one-tailed test or two-tailed test. Okay. Just one indication or one guideline that sometimes we might be confused that if our hypothesis is relevant to like one side of the distribution or both sides of the distribution, if we are confused, then it's better to go for two-tailed test. Okay, that means if we are not sure that are we testing that a mean value is greater than the benchmark or less than the benchmark, that means which side of the distribution is involved. So either one side is involved, or two sides is involved. If we have any confusion relating to this, it's better to go for two-tailed test. The two-tailed test that we already discussed, then chi-square test. So just in the last two slides, as we discussed about t-test, I said that t-test is particularly suitable when we are comparing whether a particular observation, a particular variable is different from an observed value. Okay, so that was t-test. Now it's a different test, it's a chi-square test. I already mentioned that chi-square test is a non-parametric test, and this chi-square test is applicable, or chi-square test is suitable when we have an less than interval variable. Okay, less than interval variable. That means if we have a variable that is nominal or ordinal, then we should use chi-square test. And I just also mentioned 2 slides back that chi-square test is particularly applicable when we are comparing a distribution, whether the distribution is same or different from an expected distribution. That means if the observed distribution or observed frequency is different from an expected frequency. Keep it in mind, in t-test, we compare the mean value. Okay, mean value. For example, mean income level is same, mean customer satisfaction is same, mean employee satisfaction is same, or mean income and expenditure are same. Okay, so we compare the mean difference. But when we go for chi-square test, we do not compare mean. What we compare? We compare frequency, or we compare distribution. That means we compare that if the frequency is the same or different, or if the distributions are same or different. That means if the distribution between two variables, if the distributions are same as the, like observed distribution is same as the expected distribution, or observed distribution is different from the expected distribution. So that's a difference between t-test and chi-square test. It's very important that you clearly understand that what statistical test is suitable in which circumstance. Okay. As you will get your assignment 2, you will find that you will be given a data set, you will be given some questions, and you need to answer these questions by doing some hypothesis testing, analyzing the data. Okay, so in those hypothesis testing, you need to use some statistical test. Okay, that's why for each statistical test that we discuss, you need to clearly understand that which circumstance you use this statistical test. Keep it in mind, doing the test is simple. Okay, like previously, earlier, the doing the test was a challenge because we used to do it manually. But nowadays, since you have computer softwares, doing the test is simple. So what challenging is, you need to understand the question, you need to understand the data you have, and deciding what statistical test you should use. That's the most challenging part. That's why, like when we are talking about t-statistic, when we are talking about chi-square test, be clear that which variables, which circumstance, which type of questions make this test suitable. Okay? Just if I remind again, chi-square test is suitable when the variable is variable is different. Variable, first of all, you need to understand the measurement scale of the variable. Okay? If variable is interval or ratio, then you should go for t-test that we just discussed in the last slide. Okay? But if the variable is nominal or ordinal, then you can use chi-square test. You understand my point? Okay. Now, does it necessarily mean that for any cases of interval and ratio scale we will use t-test, and for any cases of nominal and ordinal we will use chi-square test? No. That's the first condition. That's the first condition, that if you have interval or ratio scale variable, use t-test, and if you have a nominal and ordinal variable, use chi-square test. That's the first condition. Second condition is, if you are comparing between two means, if the two means are different, then you use t-test. Okay? When you are comparing, if mean of this variable is different from this variable, if mean of this variable is different from a certain benchmark, use t-test. However, when you are comparing, you have a nominal and ordinal variable, and you are comparing frequency, not mean. You are comparing frequency, or you are comparing whether observed frequency is same as the expected frequency, or if you are comparing distribution instead of mean, then we go for chi-square test. Okay, so look one example about chi-square test. So as I already gave you an idea about this example is about a restaurant. Okay, and the restaurant has 100 branches, and expected frequencies, that means it's an expectation that the branches of the restaurants are equally distributed between shopping malls, shopping centers, and a standalone location. Okay, there are 100 branches. That's the expectation, that they are equally distributed in shopping center and standalone location. Now, a researcher actually collected data on the location of each of the branches, and they find that 60 of them are located in standalone location and 40 of them are located in shopping center. Okay? Now look, what is the expected frequency? These are the frequencies, 60 in standalone location and 40 in shopping center. This is your actual frequency, isn't it? This is what you get by collecting data. This is your actual frequency. And what is your expected frequency? Your expected frequency is good. Your expected frequency is 50-50 because you are expecting that this the restaurants are equally distributed in standalone and shopping centers. Okay? So look, this is your expected frequency. You have 100 branches, 100 stores, 50 of them are located in standalone location and 50 of them are located in shopping center. So this is what you actually have, and this is what you expected when you initiated this research. Okay? Now, to do the chi-square test, we actually need to calculate this chi-square statistic. Okay? This, you can see it looks like English letter X. Then we put a square. This is a notation that we call chi-square. So we actually need to calculate chi-square statistic. Okay. So how do we calculate this chi-square statistics? You can see this is O minus E. O means our observed frequency and E is our expected frequency. Okay. Observed frequency and expected frequency divided by our expected frequency. So we have different cases of this observed frequency and expected frequency, and then we sum them up. You can see, you know this notation, this one? No? This notation is summation. That means you sum them up. Okay. So, is the equation clear? Don't worry, you need not to calculate this. I'm just showing you the equation, but you don't need to calculate this because if you have the data, you can get the result by using Excel. Now, look how do we actually calculate. So, this is our observed frequency, if you can remember, 60-40. Okay? And this is our expected frequency, 50-50. So, 60-40 observed frequency, 50-50 expected frequency. Then what we do is observed minus expected. Okay, so what is our observed? 60. What is our expected? 50. 10. Observed minus expected. Observed minus expected. Minus 10. And we divide it by expected. So what is our expected here? 50. And we divide it by expected, that is 50. So if we sum them up, 2 and 2, we get a chi-square statistic. Chi-square statistics, that is 4. Okay? So we get a statistic. Now, what we need to do is, we actually have a critical chi-square statistic. Critical chi-square statistics means, we have a particular number of observations here, and we have a particular significance level, maybe 1%, 5%, or 10%. Based on number of observations and based on a particular significance level, we have a critical chi-square statistic. Critical means, once again, a preset or predetermined chi-square statistic. Okay? So we will compare this calculated chi-square statistic with that critical chi-square statistic, and we will get a p-value. You can remember we talked about p-value earlier. We will get a p-value. Once again, we don't need to do this comparison and we need to calculate them. Excel will do that. I'm just telling you the process. So this calculated chi-square statistic will be compared with the critical chi-square statistic, and a p-value will be calculated. A p-value will be obtained. So once you get this p-value, then the process is same as we discussed earlier. The p-value will be compared with our significance level, and if the p-value is less than the significance level, we will reject our hypothesis, and if p-value is greater than the significance level, we will accept the hypothesis. Okay? So, just remember one thing, if you go for chi-square test that we just discussed, t-test that we discussed in the previous slide, we will be discussing t-test in the next class as well, because we have bivariate t-test. We will also be discussing about ANOVA. We will discuss regression. Keep it in mind, in all these cases, whether we accept our hypothesis or reject our hypothesis, the process is always same. We will get a p-value. Okay? We will get a p-value. That means the statistical softwares will give us a p-value, and we will compare the p-value with the significance level. So if the p-value is less than the significance level, we will reject. Otherwise, we will accept. Now, this chi-square statistic is 4, and if you compare it with the critical chi-square statistic, and if you obtain the p-value, you will find, I didn't show it here, you will get it in your textbook. If you calculate your p-value comparing them, you will find that the p-value is less than 0.05. So p-value will be in fact something 0.04. So p-value will be less than the significance level, that means say 0.05. So if your p-value is less than the significance level, you reject your null hypothesis. Okay? Now, in this case, if you reject your null hypothesis, can you tell me what is your conclusion? If you reject your null hypothesis, in this example, what you conclude? You want to say anything? You picked the alternate hypothesis, good. What was our null and alternate hypothesis? Can you remember? Like, first, what was our null hypothesis? Can anyone tell me what was the null hypothesis in this example? Anyone? What was the null hypothesis? Equal, good. Equal. It means our null hypothesis was the restaurants are equally distributed in shopping center and standalone location. Or you can say that our null hypothesis was the expected frequency and actual frequency was same. So what was our expected frequency? 50-50. So we expected that our expected frequency and actual frequency is same. Or, in other words, you can say that our null hypothesis was the restaurants or the stores are equally distributed between standalone location and shopping centers. So what do you conclude? We reject our null hypothesis. So we reject our null hypothesis, that means we accept our alternate hypothesis. Okay? So what conclusion? Accept our alternate hypothesis or reject null hypothesis, that is what is statistical conclusion. What is the non-statistical conclusion? Okay, so non-statistical interpretation is, first of all, that they are not equally distributed. Our null hypothesis was they are equally distributed. As we reject our null hypothesis, it means that they are not equally distributed. They are not equally distributed, and if we look our observed frequency, we can see that number of stores in standalone location is significantly higher than the number of stores located in shopping centers. Yes or no? Again I said, since our chi-square statistic is 4, it's and comparing it with the critical chi-square statistic, we get that our p-value is less than the significance level, so we reject our null hypothesis. So what was the null hypothesis? that our restaurants are equally distributed between standalone and shopping centers, so we reject our null hypothesis. It means that they are not equally distributed between these two locations. Rather, we see that restaurants in standalone locations are significantly higher than the restaurants in shopping centers. Okay, so when you run a statistical test, you get a result, you need to provide two interpretations. One is statistical interpretation, another is non-statistical interpretation. Don't worry, you will have a lot of workshop questions in the next few weeks, and you will see how do you answer these questions. But initially, as I said, that you need to provide two interpretations, statistical and non-statistical interpretation.